Hi guys. Okay, so we just got done learning how to solve systems, but I taught you how to solve systems by graphing. So we graph two lines and wherever the intersection point is our solution. Well, that way works, but it is not the best way. Okay, and here's why. So I'm going to have you pause the video and actually write this down. Yes, I want you to write it down. So pause the video, copy it down, and then hit play when you're ready to talk about it. Okay. So what this says is solving systems by graphing is not the best because the intersection point isn't always pretty. So where the lines cross, so far, I've been really nice with the problems that I give you. I know, or I make it so that the equations intersect so that the lines intersect at a nice whole number, you know, -2,5, right? Well, that's not always the case. You're going to have lines that don't intersect at nice whole numbers, and it's going to be, you know, decimals or fractions. And we can't really guess what the intersection point is. We have to have an exact amount. So this is why systems are usually solved algebraically. So we're going to usually use substitution to solve or elimination. So today's lesson and this week's lesson is all about substitution. But I really want to make this make sense to you, why graphing isn't always the best. It works, it's just not always the best. So down here, I got my system. Probably should have put the little squiggly guy over there, okay? But I'm going to go ahead and graph these and we'll see what happens. So y equals 3x minus 2. So the y-intercept is at -2. My slope is 3, so that's up 3, right 1. 1, 2, 3, right 1. I could also go down 3, left 1. I'm going to take those points, use a ruler, and there is my graphed equation. Okay, now I'm going to take this other line, this other equation in the system, graph that. Intercept is at +5 on the y-axis. The slope is -5, so I'm going to go down 5, right 1. Connect those 2 points. Okay, and then look at your intersection point. Can you see that? That little intersection point right here. I'm hoping you can see that. That is not at a whole number. And we can't just like guess. We can't just be like, oh, that's pretty close to 1. No, it has to be exact. So I'm just showing you why graphing is not always the best, okay? So we have to solve it, know how to solve it algebraically, and there's 2 main ways to do that, substitution or elimination. You're going to see that I prefer one over the other, but the thing is we can't know how elimination works without knowing substitution first. So it is kind of a sequence thing. So let's talk about just the word substitution. So to substitute, this is your vocab word of the day, substitute. To substitute something in, I mean, you can think about having a substitute teacher. It's your replacement of your teacher for the day, right? You can think of it as a basketball coach or volleyball coach or whatever coach subbing in a player. They're replacing that player with somebody else, okay? That's how I want you to think of substitution. It's to replace or plug in. And you're going to hear me say that a lot too, plug in, right? So just a quick little vocab. Okay, now let's actually do this. Let me show you what substitution really is. So here is question number 1. And we're going to do this like step by step, just so it's very clear. We're going to be writing little notes to ourselves, everything like that. So here is your system. So let's write it first. 2x minus 3y equals 26. 2x minus 3y equals 26. The second equation is x equals 10. Okay, so we're going to group that up, show it's a system. Okay, and this one, you might be looking at the second equation going, I don't see a y in there. Well, guess what? We already know one of the values. We already know that x is 10, excuse me, x is 10, and that's like a gift. So remember for graphing, like we have to have an x and a y value. Well, you already have your x coordinate. It's going to be 10 comma something. Okay, so that's a gift to us. It did half of the work for us. Anyways, here's a little notes I want you to write off to the side. Okay, if x equals 10, comma, then replace x with 10 in the top equation. So if x equals 10, that means x is 10, then I should be able to substitute or replace or plug in a 10 right here for the x in that top equation. So let's go ahead and do that. We're going to do that right here. So instead of 2x, I already know x equals 10. So I'm going to plug in a 10 for my x. And then I'm going to keep copying down the rest of the equation. Okay, so I still have a variable to solve for. In this case, there's only one variable. We know how to do that. We just have to get y by itself, but we got to simplify first. 2 times 10 is 20. So I have 20 minus 3y equals 26. Got to get y by itself, but first we got to get rid of that 20. So I'm going to move 20 over. Since it's positive 20, I subtract 20 to move it. 20s cancel, I'm left with negative 3y equals 26 minus 20 is 6. And then how do I get y by itself? Just divide by whatever's attached to it. Got to divide by 3 on both sides, and we get y equals negative 2. Okay, so here's what you need to find. In order to solve a system, you need to know the x, y ordered pair. You need to know the value of x, the value of y, and how we list it is as an ordered pair. This problem was generous because we already knew that 10 was the x value. It already gave it to us. We had to plug in 10 for x, and we solved for y, and we got our y. Y was negative 2. So right here, this is my solution. In fact, why don't you go ahead and put solution right here. Our solution is 10 comma negative 2. Now, if you're like, wait, what? By the way, if you're thinking this is too easy, it's because this one is a pretty nice one. We're starting off kind of easy, okay? But let's check it. If you don't trust the magic that I just did, let's go ahead and check it. We're going to check to see if 10 comma negative 2 is the solution of this system. We had a whole lesson on this, how to check. Replace x and y in each equation and see if it's true for both. It has to be true for both. So let's check. So let's take this top equation. I would do 2 times my x value minus 3 times my y value maybe equals 26. Okay, 2 times 10 is 20. Negative times negative positive, so that'd be positive 6. 20 plus 6 is in fact 26. So it works for that one. It's a yes there. If we replace x and y in the second equation, well, there's only one variable to plug in. It's your 10. So we get 10 equals 10, and that's a yes. So overall, we did find the correct solution. 10 comma negative 2 is your correct solution. Okay. Okay, so the word substitute came in handy here because we substituted 10 in for x, and then we were able to solve for y. Okay, let's look at another problem. They're going to kind of increasingly get more difficult as we go. Here's number 2. Number 2, here's your system. Here's the first equation. 8x minus 6y equals 10. 8x minus 6y equals 10. Second equation, x equals y plus 5. X equals y plus 5. Okay, so that's your system right there. All righty. Now, let's kind of write out some steps for ourselves. We'll call this step 1. So this is all about substitution, or plugging in or replacing. So something I notice is that x is isolated right here. X is by itself on one side of the equal sign. In the last problem, it was really great because it was x equals and then just a number. Like we already knew what x was, right? That was already part of our answer. But right here it says x equals y plus 5. So it's not quite solved for. Like we don't know what x is at this point. But this y plus 5 is actually what you're going to replace x with in the top equation. Okay, so let's write that. And then we'll do it, okay? So here's step 1. Replace x in the top equation with, and then look at what your x is equal to. Your x is equal, it's the same as y plus 5. So I'm going to take y plus 5 and I'm going to plug it in for x right there. Okay, replace x in the top equation with y plus 5. And I'm just going to really hopefully make this make sense by saying since x is y plus 5, or x equals y plus 5. Okay. So equal sign means they're the same. If x is the same thing as y plus 5, well, I get to replace x with y plus 5. Okay, so let's see what that looks like in here. Okay, this is where it's so important that you use parentheses when you substitute things in. This is where it really comes into play. So right here with the 8, I'm going to plug in or substitute in the stuff that's equal to x. And in this case, x equals y plus 5. All of that gets put into parentheses, and that's what I'm replacing x with. I'm going to keep copying down my equation. So minus 6y equals 10. Okay. Now, if you look through here, we only have one type of variable that we're left with. We have some y's. So we're going to solve for y. Okay. So let's go ahead and do that. I see some distributive property. That has to be done first. 8 times y is 8y. 8 times 5 is 40. Drop down the other stuff. Okay. Now all of my variables are on the left side, so that's good. But I do want to combine like terms. So let's go ahead and combine 8y minus 6y, and that's positive 2y. Drop down the other stuff. Okay, so all of my variables are to the left. That means I want to move all the other numbers, your constants, to the right. So subtract 40 on both sides. 2y equals negative 30. Got to get y by itself, so we divide by 2. Y equals negative 15. Okay, I'm hoping the solving isn't what you're stuck on because, you know, that's from trimester 1. Okay, so here we go. Y equals negative 15. We have part of our solution. And in fact, let's go ahead and maybe like right here, let's write solution. Okay, we already know part of it. We already know that the y value is negative 15. So we know what y is. Now we just need to figure out what x is. So we substituted in the first step. Well, guess what? You're going to substitute or plug in negative 15 for y in either one of your equations. So we're going to plug in negative 15 for y and then solve for x. Okay, so we'll call this step 2. I'm going to do it over here. Step 2. Okay, so step 2, we're going to write this in words. Plug in negative 15 for y in either equation. So you can plug it in right here, or you could plug it into the bottom one right there. Doesn't really matter, okay? You're gonna get the same answer. So you're gonna plug it in and solve for x. Okay. Now you should probably look at your choices. Like I told you, you could plug in negative 15 for this y and then solve for x, or you could plug it into the second equation for y and solve for x. You'll get the same answer, but plugging it into the second equation is actually going to get it quicker because our x is already isolated and there's less numbers to multiply by and stuff. So I'm going to choose to plug it into the second equation. So instead of x equals y plus 5, I'm going to do x equals, and then here's my y value. My y value is negative 15 plus 5. So all I did was replace this y with what y is equal to. Plugged in a negative 15 right there. And now look at this. This is super easy. X is already by itself. We just got to do this real quick. Negative 15 plus 5 is negative 10. So we go right here. Our solution is negative 10 comma negative 15. Okay. So if you were to graph those points, that would be the intersection point. Okay, so this is one where it'd be okay to graph. You would get a nice whole number answer, but they don't always end up that way. Okay. So this is the question that you're gonna kind of enter as an entry test question. I'm gonna help you do half or almost 3/4 of it. You just have to kind of finish it up on your own, okay? But feel free, if this makes sense to you, feel free to pause the video and just try it without me, okay? Won't hurt my feelings, I'll be proud. So here you go, y equals 4x minus 1. Second equation, 2x minus y equals negative 5. Okay, group them up. So there's our system, and we have to solve for x and y in each, okay? And we're solving by substitution. We're not graphing this off to the side. We're solving by substitution. So first thing I look for is to see if any of my variables are already isolated. In the first problem, x was isolated. And it was nice because it told us x is 10, right? It's half the problem for us. This one, it had at least x isolated. See how x is all by itself on an equal sign? That's good news for us. It makes our life pretty easy. We knew right away that we just plug in y plus 5 for x, okay? On this one, do you see one of the variables that's already isolated? Do you see which one is already by itself on one side? This y. This y is already isolated. So what that means to me is that this is what I would be substituting in. This is the expression I would substitute in for y into the other equation, okay? This says here, we substituted in this expression for x because x was equal to that. Since y is 4x minus 1, I'm gonna replace this y with 4x minus 1, okay? So let's kind of write down our steps. You won't have to write it in words every time, but for this video, yes, okay. So step 1, let's say since y equals 4x minus 1, comma, replace y in the second equation with, and then kind of answer that yourself. What are you going to replace y with? What does y equal? It equals 4x minus 1. Okay, so let's go ahead and do that. So I'm going to be taking the second equation and plugging in for y. So I'm going to copy it down, 2x minus, and then this is where I plug in stuff. It is important that you use parentheses because you have multiple things that you're plugging in, multiple terms that you're plugging in for y. So we need to make sure that we protect the 4x minus 1 with parentheses, because you'll see you're going to end up with some distributive property. So that's why it's important to always plug in with parentheses. Keep on writing it, equals -5. Okay. Okay, so let's go ahead and we can see we only have x's. So we're solving for x now. So let's go ahead and do some distributive property here. That's basically a -1. So it would change it to -4x, and then negative times negative, positive. Okay. Drop down all your other stuff. And I would challenge you to pause the video and see if you can get this. I'm going to help you solve this, but pause it. You should know what to do. Simplify over here. 2x minus 4x is -2x. All my variables are to the left, so I want to get this 1 to the other side. So I'm going to subtract 1. So I have a -2x equals, and then -5 minus 1 is -6. To get x isolated, I divide by -2 on both sides. Negative divided by negative, positive. So x equals 3. So I gave you half the answer right there. We know that in our solution, it's going to be 3 comma something. Okay. Now I'm going to ask that you do step 2 kind of without me. I will get you started. We will write what to do. You just have to actually do it. Okay. Now that you know what x is, you are going to plug in or replace or substitute, whatever vocab you want to use. You're going to plug in 3 for x. Plug in 3 for x in either equation. So you get to choose which equation you want to plug in for. Solve it into either equation and solve for y. So I helped you with like 3/4 of it. You just need to actually do this. Plug in 3 for x in either equation and solve for y. And then once you get y, you're going to plug it in right here. How you enter in your final answer as the practice question, because this is your practice question. I'm looking for the ordered pair. Parentheses, 3 comma something, parentheses. That's how you write your final answer. Okay. Okay. And if you're not loving this, just know that we will practice more in class, right? That's why we're doing this. Okay. See you guys.